Hi, my name is Maya Ram, and today I'll be presenting on Mammoth Cave and Hot Springs National Parks. I'll cover their geology, climate history, human impact, and much more, starting with Mammoth Cave. Hope you all enjoy. First, I'm going to talk about Mammoth Cave National Park. As you can see on the map above, this national park, located in the southeast of Kentucky, spans approximately 53,000 acres and protects the world's longest known cave system, with over 400 miles surveyed to date, according to the National Park Service's article Geodiversity Atlas Mammoth Cave National Park, Kentucky. Moving on to the geological history. According to the National Park Service's Geodiversity Atlas, Mammoth Cave National Park, Kentucky, the cave's history began around 350 million years ago during the Mississippian period, when a tropical sea covered the area. Marine sediment formed the limestone layers seen in the image on the right. Then, around 320 million years ago, the Big Clifty sandstone was deposited. The Kentucky Geological Survey report on the geology of the Mammoth Cave area, published by the University of Kentucky, explains that the Big Clifty sandstone acts as a cap rock, helping to preserve the cave systems. According to the National Park Service's webpage, stasolites, stalagmites, and cave formations, Mammoth Cave has been used by humans for over 12,000 years. The article explains that early populations mined minerals such as gypsum, seen in the photo on the left, and mirabilite, shown on the right. The National Park Service's Mammoth Cave World Heritage Site article adds that Mammoth Cave was officially designated a national park in 1941 and has since been internationally recognized for its scientific and cultural significance. Moving on to the regional and geological connections, according to the National Park Service's Geodiversity Atlas, Mammoth Cave National Park, Kentucky, Mammoth Cave sits on the southeastern edge of the Chester Upland, a rugged area capped by erosion-resistant sandstone. The atlas explains that the Green and Nolan rivers carve through this landscape, shaping the topography seen in the image on the right. It also notes that while erosion and tectonic uplift played major roles, there is no significant volcanic activity linked to the cave's formations. According to the National Park Service's Geodiversity Atlas, Mammoth Cave National Park, Kentucky, the park's rock layers preserve ancient marine environments and climate history. The image on the right shows marine fossils like corals, gastropods, and brachiopods from the Mississippian period. The atlas also notes that Mammoth Cave's limestone karst systems, seen in the bottom image, are sensitive to temperature and precipitation shifts, which affect groundwater flow and cave development. The National Park Service's Rocks of Mammoth Cave page notes that climate change may reduce groundwater and slow new cave formation. Moving on to our next park, Hot Springs National Park is located in Arkansas, as shown in the map above. According to the National Park Service's Geodiversity Atlas Hot Springs National Park, the site is around 5,000 acres and it was originally established as a reservation in 1832, which makes it the oldest protected land in the United States. According to Carl Haywood in the National Park Service's Historic American Building Survey, the foundation of Hot Springs National Park is made up of Paleozoic sedimentary rocks like sandstone, shale, and chert, as shown on the map above. Haywood explains that the oldest layers, including the Big Fort chert and Missouri Mountain shale, formed between the Ordovician and Mississippian periods. The Geodiversity Atlas Hot Springs National Park notes that tectonic forces during the Ouachita orogeny folded these layers, and the region later alternated between marine and terrestrial environments, shaping its geology. According to the National Park Service's Geodiversity Atlas, Hot Springs National Park, the site was redesignated as a national park in 1921, and the hot springs shown in the image on the right were historically used by indigenous people and European settlers. A 2024 study by Lee and colleagues in Science of the Total Environment adds that the use of the hot springs eventually led to a global trend of promoting hot springs for therapy. According to the Climate Change Hot Springs National Park webpage, the Ouachita orogeny folded sedimentary layers into the Ouachita Mountain, and then erosion later exposed these ancient formations. The page adds that while not volcanic, the hot springs result from groundwater descending through the deep fractures, heating up from Earth's internal heat, and rising back to the surface, a process that still defines the region's hydrology today, as you can see in the image above. According to Carl Haywood from the National Park Service Historic American Building Survey, the rock of The rocks of Hot Springs National Parks are rich in fossils that offer clues about past climate conditions. Marine origin rocks like chert and shale confirm the area was once covered by a warm, shallow sea, and fossil evidence of graptolites, shown in the image on the right, further supports this marine history. The Climate Change Hot Springs National Park webpage adds that rising temperatures and less predictable precipitation could lead to more frequent droughts and wildfires, which could affect vegetation, water availability, and overall ecosystem stability. In conclusion, Mammoth Cave National Park and Hot Springs National Park, shown in the images above, are regionally and geologically connected with shared features in their rock formations and climate history. Both parks have experienced major geological events. Mammoth Cave's limestone karst system and Hot Springs marine origin rocks such as chert and shale, point to ancient shallow seas that once covered these regions. The Ouachita orogeny, which shaped hot springs, also influenced the broader landscape, linking both parks through tectonic history. Over time, climate shifts have affected each park's hydrology, temperature, and ecosystems, changes that continue to shape their future to this day.